Hello everybody and welcome back to Rockpile Tutors Homework Helper. This time we're going to 7th grade and talking about solving systems of linear equations. All right, here we go. This was sent in by someone who has decided that she is my favorite student, and I agree. So what we're doing here is we're solving systems of linear equations. And what we're going to get is two different equations, and we're going to find an x and a y that is a solution to both equations. Now the way we can do this is there are three methods. One is graphing. The second method is substitution. And the third is elimination. As you do more of these, you will develop one that you like the most, but it's important to understand how to do all three because different systems will lend themselves to using a different method most successfully. They can all work, but sometimes one will be clearly easier. We're going to start with graphing. So here we have the equations 4x plus y equals 2 and x minus y equals 3. So to graph these most easily, I find converting them into the y equals mx plus b form to be the easiest. And so I will rewrite this first one as y equals minus 4x plus 2. And I do that by subtracting 4x from both sides to isolate the y and get it on its own. This one, because I want the y to be a positive, I'm actually going to move the y. And so I'm going to add y to both sides, and then I'm going to subtract 3 from both sides. So I'm going to end up with, right, y moves over here, I'm going to end up with y equals x minus 3. Now the way we're going to plot these is we start with the y-intercept. And so for the purple equation, we are going to start at y equals 2, 0, 2. And then our next point is going to be from there going with a slope of 4, a slope of negative 4. Now negative 4 means I either go down 4 and then over 1 positive, or I can go up 4 and to the left 1. So that as long as one of my rise or run is negative, the slope will be negative. And then I can draw a line to connect these. 1, 2, 3. Going about from there, and it should go through. Yeah, pretty darn close. And that is my purple line. Okay. Next, I will use my red line. And again, I'm going to start with a y-intercept of negative 3. So that's going to be right here. And then my slope of 1, because if you just have an x, the coefficient is 1. My slope of 1 is going to be up 1 over 1 or down 1 to the left 1. All right, similarly, I'm going to draw my line. And now we can see the magic here. Because the point where they cross is the only point that solves both solutions. Because every point, oops, that's a problem. I didn't. Let's make that red to make it clearer. What am I doing here? Oh. Point is the only point that is on both lines. And we can see that because every point on the red line here, or the line that should be red, is on the line y equals x minus 3. And every point on this first line is on the line 4x plus y equals 2. And so this is the only point that is in both of them, and therefore it is the solution. And we write that as 1 comma negative 2. So this is 1 comma negative 2 is the solution. All right. Now for substitution, we do this all algebraically. So we start by writing both of the equations down. 4x plus y equals 2, and x minus y equals 3. So what we're going to do for substitution is we will solve one of the equations for one of the variables. So in this case, I'm going to solve for x. So to solve this equation, I'm going to add y to both sides. So now my second equation is x equals y plus 3. And now what I'm going to do is I am going to take that definition for x and I'm going to plug it in to x in the first equation, which will leave me with 4 times y plus 3 plus y equals 2. And you'll notice now that I have nothing but y in this equation, which is back to the solving algebraic equations that you've already done. So first I will distribute, and making sure to get all of the terms and the correct sign. I have 4y plus 12 plus y equals 2. And now I'm going to combine like terms and get 5y plus 12 equals 2. And finally, I'm going to subtract 12 from both, or sorry, not finally. Next step, subtract 12 from both sides. So I end up with 5y equals 2 plus a negative 12, negative 10, y equals negative 2. So now I've got half of my answer. And now what I want to do is I want to plug that back into the first equation and solve for x. So now I'm going to write x minus y, which is negative 2, equals 3. And now that is x plus 2, because we add the opposite. X plus 2 equals 3, subtract 2 from both sides, and I get x equals 1. And now, through a different method with no pictures at all, I'm going to end up with the same solution. 1 comma negative 2. All right, so now we have gone over graphing and substitution, and next we're going to do elimination. So in order to do elimination, I look at the two equations together. Let's go over here. Okay, and I have 4x, pardon me, for x plus y equals 2 and x minus y equals 3. Okay. So what we do in elimination is we add or subtract entire equations from one another to get the same thing we got from substitution is one of the variables to disappear. So in this case, I am going to look for the fact, or I'm going to notice that the y's have a plus y in the first and a minus y in the second. And that is the perfect situation for elimination, because now all I have to do is add the two equations. If I add each term, I get 4x plus x, or 5x, plus y and minus y is plus 0y, which is what I wanted, equals 5. So x equals 1. Now I go to the same thing and I plug that 1 into one of the equations. This one is the simplest, and I get 1 minus y equals 3. I'm going to subtract 1 from both sides, and I'm going to get negative y equals 2, or y equals negative 2. And, as you should be familiar with by now, that is our solution. So now we have done all three different methods of solving a system of two linear equations. And you are now better off. Looked at each method for solving these equations, we're now going to take this second problem and solve using each of the three methods. So let's go down here, and we're ready to go. In order to graph, what I need to do is the easiest way to graph is to turn it into y equals mx plus b form. And so I'm going to take this equation, and first I'm going to subtract 4x from both sides. We'll come down here, and that gives me 2y equals minus 4x plus 10. Now I'm going to divide both sides by 2, and that means I need to divide all of the terms over here, because whatever I do to the left, I do to the right as well. And now that's going to give me y equals minus 2x plus 5. And so what we're going to do is we are going to plot this, and I'm going to start by going to my y-intercept, which is 5. And then I'm going to go down 2 and over 1, down 2 and over 1, and then I'm going to draw my line. And pretty good. Okay. And now I'm going to do the same thing with the other equation. I want to set it into y equals. So I'm going to add y to both sides. And then, where are we going to go? That's going to give me, we'll go right here. That is going to give me x equals y plus 13. Subtract 13 from both sides. And I get y equals x minus 13. So here I'm going to go down 13. 1, 2, 3, 4. Let's say that's about there. And then I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, and draw my line. Purple. And to get them to cross, what's going on here? Let's extend that there. And this answer, right, and this is the downside of graphing, is that we're not going to be as specific to be able to find it. But this is going to be about 1, 2, 3, 4, 5, 6, 7, 8, 7. 1, 2, 3, 4, 5, 6, 7. So this is going to be about 7 comma negative 7. So you can see the quickness of graphing, but unless you have a very defined grid, it can be hard to find the actual solution. Next, we're going to do substitution. And here we're going to solve for the easier one, which in this case will be solving for x. So I'm going to add y to both sides, and I'm going to get x equals y plus 13. Take that, substitute it into the previous one, and I get 4 times y plus 13 plus 2y equals 10. Distribute. 4y plus 52 plus 2y equals 10. 6y plus 52 equals 10. And I get, so that's negative 50, minus 52. 6y equals negative 42. Divide by 6. And looks like I got lucky that y equals negative 7. Plug it back in here, and I get x minus y equals 13. This is negative 7. And so I end up with x minus negative 7 equals 13, which means x plus 7 equals 13. X equals 6. So I was close, you can see. But my solution here will then be 6 comma negative 7. Okay? And the last thing we're going to do is elimination. Now here, we don't have it as simple where we can just choose to add or subtract. So this is going to take an extra step where I'm going to force one of these variables to get eliminated. So here I'm going to get rid of the y again, and I need minus 2y. So I'm going to take this entire equation and multiply by 2. So now, instead of that, now I have 2x minus 2y equals 26. And as long as I do the same thing to both sides of the equation, I'm golden. And now if I ignore this and I look here, I know that I can add again and get rid of my y. So now when I add, I will get 6y, 6x, plus 0y equals 36. That goes away. And so now if I divide both sides by 6, I get x equals 6. Plug that into here, and I get 6 minus y equals 13. And now I'm going to subtract 6. And I get negative y equals 7. Or y equals negative 7. In general, elimination is my go-to method for solving linear equations. I tend to see it better, but there are definitely times where the other makes sense. So 6 comma negative 7, and we get the same answer each time. So that concludes this problem, and I wanted to thank everybody for watching. Hopefully you learned something, and remember, you can always come see us for more at rockpiletutors.com. See ya.